Okay, so Leetcode 179 bi-weekly. I'm 15 minutes late, but who cares? Maximum absolute difference between. Maybe if it would load, that would be great. So valid pairs are if minimum absolute difference among all valid pairs. Okay, so max diff is n len, let's call it ans, len nums, for I in range n, for j in range I plus 1n, if nums I1, wait, if x nums I nums j x sort, if x is equal to 1 2 ans min ans j minus I, return ans 2 minus 1 minus 1 if ans n, else ans 2 minus 1 submit. Okay, next problem. Direction assignment, oh, from 3 to 4 and another 4, then it's a 6 digit sum. Okay, that's gonna be pain. Direction assignments with exactly k people visible. You are given 3 integers, and post k there is n people in line, L visible, each person chooses a direction. L visible only to people on their right, R is visible only. Okay. A person at index pos sees others as follows. A person is visible if they choose L, is visible if they choose R. Number of possible direction assignments such that the person at index pos sees exactly k people. So we got 3 people, right? And the middle person is this. To the left of pos, to the right. So to see k people must choose R, R. Okay, okay. So we are at post 2012, so last person, we want to see 1 person. So wait, what if there is like L, R, and then my person, right? To see 1 person, exactly one of those indices must choose, other must choose R. There are 2 ways to choose which index is visible from the left. Okay, so I think this is pretty easy. We do it like this. So for all, right, if we are at pos, there is pos people to the left of us, and wait, so person as pos sees person if they choose L. Okay, so basically we try. Okay, so ans is this. Oh no, I submitted it. Oh my days, that's so stupid. Okay, mod 1 in 9 plus 7. Okay, I lost a 5-minute penalty, whatever. So we go for I in range pos, right? And now this is how many people to the left of us will have L, right? How many options is that? Okay, and then J is k minus I. J is k minus I, and then we will have min pos k plus 1, I think, yeah. So to the left, I people with L, and to the right, J people with this. So Okay, well, this sucks a little because okay, how many ways? You just choose the positions, right? So that's like out of pos positions, choose I. So pos choose I, basically, is the number of ways to left, and for each of them we have n minus pos minus 1 choose j. Brother. That sucks. How am I supposed to answer this fast? Sorry. Can do like factorial n. This cannot be done so shittily. It's like 1/2. Wait. Nah, that's no. We need to do like something to -1, so def bin po x to y, result while y, if y and 1, res times x percentage mod x. Oh my god, that's Python. Okay, x times x percentage mod, and then return result. This is 1, so that's modulo, right? Then we need some factorial s to be pre-calculated. Not sure what's fastest. Fac 1 max n 1e5 plus 1 for I in range max n. Else I times fac I minus, and that's probably not gonna work, so let's do this. For I in range in range max n, factorial I times fac I minus 1. Not sure if that will pass, but whatever. And then we need like def ncr, self is the first argument. Okay, and that's nr, return factorial n times bimpo factorial n minus k 2 mod minus 2 times bimpo factorial k 2 mod minus 2, so classic, and then ans equals, so that's left is ncr. Yeah, probably this should be modulo, but whatever, let's do it like that, and this should be modulo too. Okay, and then that's left is ncr, so from we wanna choose from pos, we wanna choose I, right, and self ncr, self binpo, and that's ncr, and then n minus pos minus 1 and j, and then ans plus left, no, current left times right percentage mod, ans plus current percentage mod, return answer. Let's run it. Runtime error. Flow, what? Oh, it's what, 100k. Okay, 1 2 3. Wait, that's what, 1000 million. Okay, like that. Don't bother me with anything else. Okay, that's NCK, whatever. So this one is 1. Okay, wrong, great. This one is something wrong. That's great. Because, okay, how many ways I can place? Okay, let's go back. You are given this. Top left, want to reach bottom right, right or down. Cost of pass is bitwise XOR of all the values, including start and end, minimum possible XOR among paths. What's in the grid? Oh, that's the entire grid. Oh. What's the coordinate? Oh, million. And is this not just... that's weird. I mean, there's suspiciously shitty samples, so it may not be as easy. I mean, we can try. We can try, I guess. Okay, so at LRU cache none def dp ij I don't know. So ans 0 if I ans, no, ans is the grid ij, right? XOR it with I minus 1j if j ans XOR with dp ij minus 1 return ans return dp nm minus 1 and minus 1, whatever. Probably not gonna work, but fair enough. So let's do nm len grid 0 6. Okay, that sucks. So let's do this. Print ij ans. So for 0 0 it's 1. I agree with that. For 0 1 1 XOR 2 is 3. I agree with that. Oh. Okay, so ans equals to, what can the XOR be? 1023, so it cannot be more. 1024. Okay, and now ans min ans grid ij XOR this min ans grid ij XOR this. Ooh, wow. Yeah, but that's kind of tough. I mean, 1000. Wait, so we return grid ij if ans else ans 6 9 0 submit. Is it really that easy? No, as expected. Amazing. Use test case. So what do we output for this? Let's do result print res return res. No, ij result. So that's 26 for top left corner. and then 2 if we go here, 1 if we go here, 24. Really? What's 26 actually in binary? If only I knew how to output it. I mean, it's millions, so you somehow have to be linear. Direction assignments with exactly k people. Not sure how to try all these, to be honest. So wait, so print ij, so print to left this many, to right this many. So 0 to both sides. Oh, there is multiple options. Okay. Well, let's say choose this L, right, to see person 1, it doesn't affect so the person can choose anything. So it's always times 2. That's weird, but I guess that makes sense because in left okay, so from n-1 we are choosing k positions, and that's it. I mean, from n-1 we are choosing k positions and we multiply by 2, I think. So return self ncr n-1, because we don't really care about the position and we just want to pick k people, right? So like that, percentage mod, of course. This is 2, this is 4, and this is 2. Okay, easy. Okay, that was easier. Let's figure out this. I would need to write them down. Well, XOR is not really a minimum thing, so how many bits are there? So there is 10 bits, so maybe we could have like a minimum Well, there is 10 bits, so maybe we have to do some sort of DP also over the bits, like max bit set or something. I don't know, let's call it K, right? And then I'm not sure that will work, because I mean it could be up to 1 million, and you know it's Leetcode, so you cannot really expect. Oh, it's 1000. Oh my god, bro. Okay, so m times n is 1000. I did not realize that. Okay, alrighty. Okay, so basically now what that means is that they want us to compute that path for all possible values. So basically what that means is that what I try is this. Here I'm gonna do a DP table. 0, wait, so that's 0 for k in range k. Let's k be 1024, right? Because the XOR can only be that. 4j in range grid I, whatever it's m, and 4 I in range n, and now dp 0 0 grid 0 0 is 0, and otherwise it's minus, or let's call it like m times n, right? So that it doesn't get picked up. And then 4i in range n, 4j in range m, 4k in range k. Okay. So xk is equal to k XOR grid ij, and now if, and now dp I, if I, then dp ij is minimum of dp ij and dp I minus 1j XOR xk. No, xk plus 1, and if j dp ij k mean dp ij dp I j minus 1 xk plus 1, and then return the minimum of dp minus 1 minus 1. Yeah, that's extra bracket there. Int list. So dp ij k so the minimum XOR value among all paths. Oh my days. Okay. Okay, that's way easier, or I mean a little bit. So if I and dp ij xk, then dp ij k1, if j and dp ij minus 1 xk, this is 1, and so ans is 0. let's call it, yeah, ans 0 while ans k if dp -1 ans break ans plus equals 1 return ans 6905 should work. Maybe it's DLE, but I mean, I hope not. So n is equal to, okay, great. And let's do problem 4, which should be just 6, but we'll see. So count non-decreasing arrays with given digit sums. Oh my god, bro, hell nah. I hate digit DP with passion, and that's why I should get good at it. Digit sum length is 1000 and digit sum I is considered valid if all values are in this range. It's non-decreasing, in other words, it's larger than or equal to, I guess, sum is equal to, if sum of the digit, what? Return an integer denoting the number of distinct valid arrays, since the answer may be large, return in modulo. So basically, so this is numbers here. Oh my god, bro, what the hell? So digit sum length 1000 and each number is, okay, so I think it will be a dpij. So it will be dpij where it's what, sum of return integer denoting the number of distinct valid arrays. So dpij, let's start. So dpij, number of arrays from first number of arrays of length I for digit with last element being j, with last element being j, that's it, because then the DP is easily solvable, because n len digit sum, because basically, right, I just need to check that because, okay, so last element being j. And now what are transitions? Well, we go for I minus 1 and it's sum of arrays of whatever, right? So for each number, right, so dp is equal to, let's let k be 5000 and then do 0 for j in range k plus 1, and we actually will probably only need that, but whatever, right? And then for for j in range k plus 1, right? And now if j equals, wait, so I can pre-cal, no, okay, so dx is equal to sum of map list of string of j. No, that's bad. Okay, so dx self sum of j, def sum self x ans while x ans plus equals x percentage 10 x divided by 10 return ans. Great. So that's digits. And now if dix don't equal digit sum j, continue, otherwise no, we don't actually want continue. So if it's equal, if j dp0j dp0j minus 1, and if it's same, then we just do boom 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 dp0j plus equals 1. Okay, plus equals 1, that's great. And then for I in range 1n, for j in range k plus 1, so we go through the numbers, and now we want basically sum over something. So because if we do prefix sums on, like, let's say we have 0 0 1 1 2 3, right, and then we go here and we are like okay, like does not match, right? So there will be 1 0 0 1 0 1, right? And now here, how many ways? Well, there is just one way, right? And then here is nothing, and then here is 2 ways, right? Which is some of the previous things. And then 0 0 and then 3. And if that would be the same, I guess, but doesn't matter. Now let's say yeah, I mean, I guess that's fair. So we don't have to do prefix sums. We just need to keep some, haha, always funny. And now, okay, so digits is equal to self sum j if self sum j, then if self sum j digit sum j, then dpij plus equals this dpi minus 1j. It should be like this. Then I guess we can then swap, so that's, we don't have to do this, and then we don't have to do this, and then we do like ndp 0 for j in range k plus 1, and is equal to this, and then ndpj plus equals this, and then dp ndp dp ndp ndp dp, and then return dp minus 1 maybe, or like some of this. Oh, because there should be 0 here and high here. Six, 4, 0. Let's go. Oh shit. Oh, modulo. Okay. I forgot about that completely. That's a wasted submit, but okay. ndpj plus percentage mod. Mod 189 plus 7. Boom. Let's go. Use test case expected 1406. 1 2 3 4 5 6 7 8. Boom. Oh, but that should be moduled. Oh, okay, let's go. Funny, there is such a big like what do you call it, like maybe this self sum should be faster. Yeah, because self sum shouldn't be done every time, I think. Yeah, so let's call it sum self sum j for j in range k plus 1. Let's call it dix, whatever, dix j, boom. Let's go. Fair enough. Use test case, run. Should run fast, I think. 159 milliseconds. I'm not sure how I could make this faster. Like it's n times k. Let's go. Easy. And I started 15 minutes later. Ha! Crashed it. And I'm like 1000 or something. Probably AI solved this a long ago. Are you kidding, brother? 2500? That's ridiculous, brother. Is there really just 8 people doing this, or do they just allow access of 8 people? Okay. Well, that sucks. It's plus 20 minutes and minus 15, so minus 35. So I would be at like 40 minutes, and I'm still far off. That is crazy. Okay, so they don't even allow looking at. That's crazy. Did they disallow looking at over 200? 282 people have AK. So I'm 282nd without penalties. That's pretty decent. I guess it's not that bad. Pretty concise solutions. Anyways, let's quickly write the tutorials, and at least I got the so boom, 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 boom. No, that's not what I wanted. Recent AC, it doesn't show. Oh, okay. nobody views my solution. Guys, please look at my solutions. Oh my god, bro. I mean, I guess I could write it out into a text document and then quickly paste them in. Let's see, submissions. Can't I use them? Yeah, I cannot use it. That's weird. Okay, I will take a look into it. Okay, so let's write the editorials. So Q1. Okay, so n is small enough to try all pairs of positions ij and check if they are equal and check them. We check if nums I, nums j is either 1, 2 or 2, 1, and then we update the answer with j minus I. Try all pairs of position ij and such that ij and check them, right? Time complexity of n squared. We try all pairs and do O1 work for each of them. If we store the last occurrence really, is it typed like that? Oh, I don't know. Okay, let's leave it at that. Discard, whatever. Occurrence. If we store the last occurrence of 1 and 2, we can even do this in ON, but it's not necessary given the constraints of the problem. Space complexity of 1, since we only use a couple of extra. So I mean, I think everyone who listens to this understands. Okay, so problem number two. So essentially what this problem boils down to, if you take a look at the code, is that out of the n-1 people, right, because like direction of the post guy doesn't matter, right, and out of the n-1 we want to just choose k people, right, who will be turned in our way, and the other ones will be faced the other way, because that's what, like, if they will be faced our way, then there will be more people like visible to person at position pos. So we just need to choose out of n-1k people, but the direction of person pos is irrelevant, so we multiply it by 2. Problem is we need to do it modulo, and n choose r, of course, probably you know if you are listening to this, is that n factorial divided by r factorial times n minus r factorial. Problem is that we cannot do division modulo easily. Only way we can do this is that sorry, there is a trick in algebra which says that if we have a prime number p, then a to minus 1 is in fact equal to a to p minus 2. And in our case p is modulo, right? So but problem is our modulo is like 10 to 9, so we would be doing like multiply factorial minus n to the power of whatever 10 to 9, which wouldn't even run for one multiplication. So we use binary exponentiation, read up on them trick. Basically, instead of doing like 5 times 5 times 5 times 5, right, we do 5 times 5 times 5 times 5 times 5, right? If we have like, we want to do like 5 to the power of 5, right, which is 1 0 1, right? Then okay, this means that we take 5 to the power of 4 plus 5 to the power of 1, or multiply by 5 to the power of 1. And to solve 5 to the power of 4, we get 5 to the power of 2 times 5 to the power of 2, right? And suddenly, like, we can multiply a large number, right? And if then we have 5 to 5, 5 to 5, that's 5 squared times 5 squared times 5 to 1, right? And suddenly this is way easier because logarithm, right? And this is just some bit trick. So if we are at even, we multiply the answer. So first we started, not sure how I would explain this trick, so I haven't really explained it well, but I mean, we pre-calculate the factorials, and then here we do the trick. If I would write it recursively, I would do, so answer would be x times binpo x2y divided by 2 times binpo x divided by 2. And then, right, and the whole shtick is once you calculate 5 to 2, you don't have to calculate 5 to 2, right? So we just do log multiplications, because, you know, you could say that, okay, so we calculate, to calculate 5 to 5, we need 5 to 2 times 5 to 2, right, plus times 5 to 1, and to calculate each of these we need 5 to 1, and suddenly we are doing 5 multiplications, which is what we wanted to avoid. But you don't have to calculate this if you already calculated it. So you just do this squared, and that's the whole thing what this is doing. This is just some bit tricks. So the bit tricks say that whenever a bit is set in the power, right, which is this, we multiply it by the x, and then we move on to larger bits, so we care how many 5 to 2s are there, so we multiply it. And that's it. So that's the whole thing. Nice trick to know. Okay, I have to write it down. So we need to place, okay, so the problem statement is a bit hard to understand, but what it boils down to is to place k people into, is to count the number of ways to place k people into n-1 positions. Let it be, I don't know, ans. Finally, the person at position pos can the orientation of person at position pos does not matter. Therefore, the final answer is ans times 2. Okay, approach to place k people into n-1 positions. We simply need to calculate n-1 choose k, which is equal to fraction n-1 factorial, and this will be k factorial n-1 minus k factorial. Maybe this will work. I have no clue because I'm doing Latin without formatting. That's funny. The problem with this is we are supposed to calculate the answer modulo 1 in 9 plus 7. Let's think. So okay, there is a theorem in algebra which states for a given prime number p, a to power of minus 1 is equal to a to power of p minus 2. In our case, p is equal to 1 in 9 plus 7. So we are almost done. The problem now is that we cannot naively multiply raise a given a prime number and an integer 0 lekv a less than p. Okay. The problem now is, so the last problem is that we cannot naively raise a to the power of mod minus 2, since it is a humongous number. Instead we use binary exponentiation, which does it in log mod minus 2. So answer is what? Just log, basically. But we need to pre-calculate the factorials. N plus log of n, I guess, because k is less than n, which is equal to on, since we first have to calculate the factorials we need in on naively, and then we binary exponentiation twice to compute the inverses of nominator and denominator of the denominator factorials. Okay, so I mean, of 1 if we only store the free factorials we need for our calculations, I guess. Okay, so task free. Now it seemed a bit confusing, but when you look at this m times n, so the total number of cells is 1000 and each position is at most like from 0 to less than 10, 2 to 10. It's okay, that's like million multiplied, so we are like, oh, that's great. And now what that means for us is that the XOR along any path in any cell can be at most 1024, or it will be even less, because XOR will not create like larger number than it's possible to XOR. Like we will not get anything large if we XOR any two numbers smaller than 10 to 24, because all larger bits will be set to 0 and XOR of two zeros is still 0. So this screams a DP problem in which you calculate if it's possible to get to cell ij and the XOR of that path is k, right? So obviously in first cell only possible k is the value there, but for all the other ones, right? So let's see, can we get to cell ij with XOR k of the path? Well, we can check. We can go from upwards, right? And for that to happen, right, because the current cell also counts into the path XOR. So if we XOR these two out, because essentially like k should be equal to grid ij XOR dpi minus 1j xk, right? Or whatever. So there should be some other k, so other k, right? And then grid I, right? So, and this holds, right? Then that's great. So we would set dpij of this whole thing to 1, but we cannot try all of them, all possible values in dpij. Instead, we are forced this grid, so we can just, use the XOR property to do this, right? And that's essentially what we are doing. So basically we XOR the path's value with this, and if there was a path that got to I minus j and ended with xk, so what we need, then we set it to 1, and same with if we come back from the left column. Finally, we are supposed to find the minimum XOR value among all paths, so we just go through all XORs and check if we can get to whatever last bottom right cell with that XOR, and if yes, then stop. Okay, so that's quite clear, I guess. So the constraints are pretty small. The constraints look like we can do m times, we can do a solution in O of m times mn, like 1024 mn. So let's try to figure out something in that sense. Let our state be ij path XOR, or XOR of path, path XOR and dp should be this, and dpij path XOR equals 1 if there is a path to, if there is a valid path to cell, no, ending in cell ij with XOR path XOR. Approach. Base case is dp 0 0 grid 0 0 equals 1, dp k equals 1 only for k is equal to this, since like there is only a single path to cell 0 0 and its XOR is grid 0 0. Now to get to ij with XOR k, we can either go from I-1j or ij-1 vlog. Let's consider I-1j. What XOR would we need to arrive to I-1j with in order for us to have a path to ij ending with XOR k? K XOR grid ij, since up to k, no, that's like up to k XOR grid ij equals k. Therefore dpijk1 if dp I-1j and then that's like k XOR up to, no, grid ij equals 1. Okay. Time complexity O of mn times, I don't know, 1024 mn, since for each cell we consider all 1024 XORs, and for each of them we do O1 of work considering two cases of mn that can actually be optimized to 1000, where m is the number of rows and n is the number of calls, since whatever, since results for row I only depend on results for row I-1. Okay, And now quickly task 4. So can close this. So for task 4, this was surprisingly easy, right? So basically what we need to do, so we are doing a dpij, right? So I'm immediately gonna write out the since to calculate dpi we calculate values for dpi. We only need values from dpi minus 1. Okay, 5000 n, since there is O of 5000 n, since we first recalculate digit sums for 5001 numbers in 5000 log 5000, I mean regular O notation, and then there is all 5000 n states, and for each of them we do O1 work recalculating the cumulative sum of previous row and updating dpij. So okay, so the problem essentially boils down to the fact that, again, the range of numbers is 5000 and there is 1000 like length of the array, so we can multiply those, and that's a hint. Now, as I write here, dpij is number of arrays, right, from first I elements, like so that they match with whatever these digit sums, and I can immediately upload my solutions. Okay, so let's finish this explanation. No, that's task 3, so let's do task 4. And okay, so title is, I don't know, prefix sum plus dp. Okay, so I kind of didn't explain, but okay, let's say that's the number of arrays of length I satisfying the digit sum constraints of first I elements such that last element is j, because we don't care what the previous elements was, or if the last element was j, we know that then the next element has to be j or more, right? So then we can easily do, okay, so let dpij be the number of arrays of length I plus 1 satisfying the conditions of digit sums 0 I such that the last element is j. Okay, how to calculate each value in the table in, okay, and how to calculate each value in table in O1 approach. Base case is dp0j is equal to 1 for all j such that sum of digits of j is such that sum of digits is and n is asymptotically more than O log 5001, right? Sum of digits of j is digit sum 0. Then what is dpij in general case? Well, it's the number of arrays, valid arrays ending with j as the last element. And it's equal to sum sigma k so down k0 so it's, let's see, k0 to j minus 1 of dpij so it's equal to this because that is the number of ways we can do subarrays of length I minus 1, and the last element should be k. Last element is smaller than or equal to j, which is the element we want to place there, obviously. Okay, the problem is calculating this for each cell takes calculating this takes O of 5001. For each cell of which there are 5001n. To solve this, notice that what dpij is equal to dpij, so it's dp I minus 1j plus this whole shtick, right? So essentially, like, what's this value? Well, if we take a look at this, it's exactly dp I minus 1j minus 1, which we have calculated in the previous, right? So what I'm going for is that we essentially need prefix of the previous row, and we can easily calculate it. So i.e. we need to keep cumulative sum of values in the previous row of the dp up to the current up to j and up to dpij and including. So we need just the cumulative sum. One thing is that you need to pass is that you need to pre-calculate for each digit the sum of its digits beforehand, because then you would do it n times, which would make it too slow, at least in Python. So okay, that's it. And okay, I guess goodbye.